So the y coordinate of your vertex is your minimum, which is k. The h or the x coordinate of your vertex is going to give you your axis symmetry. It is always x equals because it is always a vertical line. Yep, so yeah.
What do those two things say, the one next to minimum and the one right there?
K says y coordinate of vertex, and x equals h is x coordinate of vertex. That's what you mean? Yeah. And again, A is what's in front of the x squared, B is what's in front of the x, and C is the constant. These in quadratic form will have an x squared and an x. You eventually will be asked how to find domain and range of these functions, right? Like domain of a quadratic is always all real numbers. Range is going to be that y to positive infinity if it's pointing up and reversed if it's pointing down. But we'll practice all of that stuff. All right, so to graph an equation that's in quadratic form, we're going to find the vertex using negative b over 2a. So if I want to find the x coordinate of my vertex, that's negative b over 2a. We would then take that and plug it back into the x to find the y coordinate of my vertex, and then from there you'll get your hk. You'll plot things like your y-intercepts, your x-intercepts, or by just plugging in points. So this is if it's in quadratic form. If it's in standard form, which you'll see in a second, that's where we can use our transformations. So first, before we even to get into specifics on this, think about what this is. If I use transformations on number one, I know it's a parabola. First of all of these are going to be parabolas, right? But is it shifted right or left at all? Is there a horizontal or vertical shift? No. What's the only change to this graph? What's that 2 on the front do? It's a vertical stretch. Yes, do we remember this? Okay, so I don't even have to do the negative b over 2a. I know my vertex is 0, 0 because there's no shift left or no shift up or down. So left or right or up or down, there's nothing, which means my vertex is at 0, 0. And then I would plug in points. So if I plug in 1, I would get 2 times 1 squared, which is 2 times 1, which is 2. And that gives me my vertical stretch. So now we have to be exact. And every parabola is symmetric. So if I went up 2 and to the right 1, I can go up 2 and to the left 1. Or you can plug in negative 1. So 2 times negative 1 squared would be 2 times 1, which is still 2. So because every parabola is symmetric, I can just go up and out the same distance I already went. If not, you want to plug in the point. So if I were to do 2, is there any horizontal or vertical transformation? Am I moving right or left or up or down? No. Okay. So I know my vertex is again at 0, 0. And if I plug in 1, I get 1/2 times 1 squared. 1 squared is 1, and I get 1/2. So this time, 1 and 1/2 is going to make it vertically compressed, which makes sense because that's what it should be. And I went up 1/2 and to the right, so I'm going to go up 1/2 and to the left. So you need 3 points for these parabolas, 1 to the right of your vertex and 1 to the left. Questions so far? Okay, so I'm going to focus on the last one. It didn't say it, but let's talk about all the stuff that we already know about this graph. We know the vertex is 0, 0, okay? The axis of symmetry is x equals whatever the x coordinate of my vertex is. What's the x coordinate of my vertex? 0. If I drew it, it'd be the vertical line that runs through 0. What's the domain of my graph? What's the domain of every parabola? Negative infinity to positive infinity. The range is my y, so bottom to top. Lowest y is 0. It's a solid dot, so it gets a bracket. And then it points up to positive infinity, so it's 0 to positive infinity. Sophia.
What's the axis of symmetry?
X equals h. So x equals whatever the x coordinate of your vertex is. And the minimum value here is the y coordinate of my vertex, which would be 0. If it asks for the coordinate point where the minimum exists, then it's 0, 0. But if it asks for just the minimum value, it's just 0. It's just the k. Okay, we're going to do that a whole bunch. So 3, what changed with 3? That hasn't happened yet. Negative on the front. What's a negative on the front do? Upside down. So there's still no horizontal or vertical shift, which means my vertex is still at 0, 0. If I plug in a positive 1, I'd get negative 4 times 1 squared, negative 4 times 1, which is negative 4. So 1, negative 4 is consistent with my graph pointing upside down. You went down 4 and out 1, so I'm going to do the same thing in the other direction and get my third point. And there's the parabola. What's my axis of symmetry? Yep, x equals 0, and it has to be an equation, so you have to have the x equals. Your domain? Domain for every single parabola is negative infinity to positive infinity. Range, this time bottom to top means I'm pointing down, right? So it's from negative infinity up to the y coordinate, which is 0. And this time, instead of having a minimum value, we have a maximum value, but it is still the y coordinate of your vertex. So if it points up, there's a minimum. If it points down, there's a maximum. Because now we're going to talk about standard form. So standard form is the form that we did when we did transformations. So if a graph is in standard form, you won't see an x and an x squared. You will see only the x squared, or you will see x plus or minus something in parentheses squared. But there will not be an x and an x squared. That's when it's in quadratic form. So with standard form, if you think about it, the horizontal shift, which is going to come from inside your parentheses, and it's the opposite direction, right? So if that's a plus, I go left. If it's a minus, I go right. That's going to match the x coordinate of your vertex because it's causing a horizontal shift. And then the number on the outside is your vertical shift, so you're shifting up and down. And that would be the y coordinate of your vertex. So I'm going to teach you how to do it like visually, and then also if you could do it just from the equation. And then the axis symmetry is still x equals the x coordinate of your vertex. So you will use transformations to plot the vertex here, but then you will have to plug in some exact points. So you have to get 3 points. They have to be exact. Vertex can come from your equation, but the other one you're going to either plug in or you can use like an intercept. But you have to get 3 exact points on this, no longer just shifting. All right, so this one is in standard form. Again, I know it's in standard form because there's only the x squared or the x plus or minus something squared. There's not an x squared and an x. So based on what we learned before the break, if I did this off of transformations, the x plus 2 is causing what kind of shift? Left 2. And the minus 3 is causing what kind of shift? Down 3. So I can find my vertex by literally doing that. Go left 2, down 3, and plot my vertex. And then read it from the graph. Vertex, negative 2, 3. Or, negative 3, sorry. Or I pull it from my equation. The h is what's opposite what follows the x, so it would be a negative 2. And then the k is the one that's at the end. I don't change the sign on it. So you change the sign on the h, you don't change the sign on the k. So you can either get it from the graph or you could get it from that. Now, is there a vertical stretch or shrink on this? No, which means from that coordinate point, where can I move to get 2 more points? Up 1, right 1, up 1, left 1. If you didn't know that, you would plug in points. Now, the difference this time is you have to plug in points. I'm not going to plug in 1 and -1. I'm plugging in the point to the right of the vertex, which would be -1, and I'd get -1 plus 2 squared minus 3. And I'd get 1 squared minus 3, 1 minus 3, which is -2. So I plugged in -1, I got -2, which is consistent with the point I had already plotted. And then I can either use symmetry to go up and left, or I could also plug in the point to the left. So 1 to the left of -2 would be -3. If I plug in -3, I also get -2, which is consistent with the point I found, -3, -2. So if there is no vertical compression or shrink or stretch, you could literally just go up 1 and out 1. If there is, then you're going to want to either use that to go up and out or plug in your points. So from here, I'm literally going to connect my points. Sophia.
When you say
Okay, so other points, because we just plugged into the right and the left, other points we could have used to find extra points are the x-intercepts. So to find my x-intercepts, what would I do? How do you find the x-intercept of any graph? Plug 0 in for what? Y. So I could have made the f of x, which is the y, 0, and then I would have solved it. If I wanted to find the y-intercept, which is a little bit easier, I plug 0 in for what? X. So let's say I did that from here, okay? I would have plugged 0 in for x. I would have gotten f of x, which is y, equals 0 plus 2 squared minus 3. Y would equal 2 squared minus 3, 4 minus 3, which is 1. So when x is 0, y should have been 1, which was this point right here. Also consistent with what we already drew. So you can also, like, it might ask you for intercepts, and you can use those instead of the plugging in of the point to the right and left. As long as you plug in at least one point to the right and then reflect it on the left. So if I count that, I went 1, 2, 3, 4, up 4, and right 2. I could do the same thing in the other direction and mirror that point on the left. So every point you get to the right of your vertex, you can mirror to the left and vice versa. Okay, so this is in quadratic form. So I'm going to teach you 2 ways to graph this. The first is by putting it in standard form. And that means complete the square. If it just said graph, I would not do it. But if it says put it into standard form and then graph, you have to do it. And there's going to be both on your quiz and both on your test. You got to learn how to do both. So we have to go back to, I don't even know what time of the year it was, but when we did complete this square, and we have to tweak it a little bit, because when we completed the square to solve quadratics, we made f of x 0, and it is no longer 0. So there's a lot the same, but a little bit the difference when we do complete the square. First of all, when we did complete the square the first time, we would have moved the 14 over. And we can't do that anymore because f of x is not 0. So the first thing I'm going to do is rewrite this so that it's y equals x squared minus 16, and minus 6x, sorry. And I'm going to bump the negative 14 out so that I can fill in this space. So we are completing the square in the same steps that we did, but we have to keep it all on one side, and that's where it gets a little bit trickier. So if you remember, step 1 was if there's anything on the front of the x squared, we had to divide everything by it, okay? Lucky for us, that's not happening yet. Step 2 was take whatever is inside the parentheses, that second term, divide it by 2, so 6 divided by 2 is 3, and then square it, and that's 9. And we would add it inside the parentheses, and we would add it to the opposite side of the equal sign, which you still can do, but at the end you're going to have to subtract it back from the 14 because you got to get y by itself. So you have that choice. Add it to both spots, but then at the end subtract it because the y's got to be isolated, or add it inside the parentheses and subtract it from outside of the parentheses so that we balance that side of the equation. So I get y equals, I'm going to factor what's inside the parentheses because we made it a perfect square trinomial. We square root the first term. We square root the last term. We take the sign from the middle, put it in parentheses, and square it. And then negative 14 minus 9 is negative 23. So this is the same thing as saying f of x equals x minus 3 squared minus 23. Now tell me what you know about that graph. What's the vertex?
3,
Good. So if I were to graph it, I would literally probably go to 3. I would probably plot a point all the way down here and just label it 3, negative 23. So if you have something that big on the homework, feel free to just do the same thing. Is there a vertical or stretch or compression? Nope, which means I can go up 1, which would be at 3. Well, I'll go up 1 into the right one first and up 1 to the left one, which means my x is still 3. No, sorry, my x is now 2. And I went up 1, negative 22. And I went to the right one, which would be 4. And I went up 1, which is negative 22. So if those were already on the graph, I would just plot them. But obviously we had to extend that graph out because my y was so big or so small. I could have also used the x-intercepts or the y-intercept. If I used the x-intercept, I would have made f of x 0, which we'll do in a little bit when it asks you. To find the y-intercept, I would go back to the original quadratic form because it is way easier to zero these out and get the y would be negative 14. So on the graph, down here somewhere, right, this wasn't accurate because we extended it out, but down there somewhere would have been my negative 14 if I wanted to use that point. So if it was all on the graph, it would be easy to just plot it. We obviously estimated it, which means it wasn't exactly there. What's your axis of symmetry? X equals 3. Again, got to be the x equals because it's got to be an equation. What's your domain? Negative infinity to positive infinity. What's your range? What's the lowest y? Negative 23 to positive infinity. Okay, we're going to do it again. Find the vertex, the axis, the x-intercept, the y-intercept, and graph. So we're going to get this into standard form, okay? This time we have something on the front of the x squared. So if I get y equals negative x squared plus 6x, bump the negative 8 out, put parentheses around those first two. And this time I have to take out a negative 1. God bless you. Now, when we solved these, because they were set equal to 0, we just divided everything by negative 1 and got rid of it. if we divide everything by -1, that y is going to be negative. So at the end, we end up having to put it back. So that's why we just keep it on the front. So take it out. Now find your third term. 6 divided by 2 is 3. 3 squared is 9. Again, I would add the 9 here. And I would normally subtract the 9 here, but here's the catch when there's something on the front. Before you can add this 9, you have to multiply it by whatever's on the front here that we took out. So if I multiply a -1 times -9, what happens? It becomes +9. So if you have something on the front of your parentheses, whether it's a sign or it's a value, like a 2, we had to take out a 2, let's say, before I add that last term to the outside, you have to multiply it by what's on the front, which means sometimes it changes it. Yes? 6 divided by 2 squared. Yep. So normally we do it on both sides of the equal sign, so you do the same thing, right? If I add to the right, I have to add to the left. But if you're adding it to the same side of the equal sign, to balance it, you have to do the opposite. So if I add it, I have to subtract it because I'm keeping it on the same side. You could also have added it here, but then you're going to have to subtract it again at the end. So it changes it again. Okay, so now I'm going to factor y equals the negatives on the front. Square root first, square root last, sign from the middle, put it in parentheses and square it. -8 plus 9, which is a +1. F of x is the same thing as y, so I didn't rewrite it, but if you had, it would be f of x equals -x minus 3 squared plus 1. Now tell me what you know about this graph. What's the vertex? 3, 1. I'm going to the right 3 and up 1. What's the negative on the front doing? It's pointing it down. So I know I'm going to go down 1 and out 1 because there's no stretch, right? But those are also going to be my x-intercepts. So we're going to practice finding those because it asks you for all of it. So the axis of symmetry is x equals 3 because it's always the h or the x coordinate of your vertex. The x-intercepts, I'm going to make y 0. So 0 equals -x minus 3 squared plus 1. I'm doing it from the standard form, but if this is factorable from the beginning, you can also do it from there. So 0 equals -x squared plus 6x minus 8. If I wanted to factor it, I could also do it from there. Sometimes it's going to be easier to do that, but I'm going to show you this way just so you know both, because it's not always going to be factorable. So from here, I would subtract the 1. I get -1 equals -x minus 3 squared. I divide both sides by -1, and I get 1 equals x minus 3 squared. I square root both sides using the even root property, and I know I'm going to get 2 answers. One in which x is going to equal the -1, and one in which it's going to equal a +1. Add the 3, and I get x equals 2. Add the 3, and I get x equals 4. So my x-intercepts are 2, 0, and 4, 0. Which if I had gone down 1 into the left 1, I would have gotten the 2, 0. Down 1 into the right 1, I would have gotten the 4, 0. Then it asks for the y-intercept, and to do that, I'm going back to my quadratic form because it is really much easier to make this 0 and this 0, and I know my y-intercept would be 0, -8. So down here would be my y-intercept, and now I've got 4 points. Sophia? Plug 0 in for x. And I do it where it's in quadratic form because that's when it's easier. It's really just the c. Domain, all real numbers, right? Range would be negative infinity up to 1 with a bracket on the 1. So same set of instructions. Again, I'm going to teach you a third way to do these if they're in quadratic form like this, where you don't have to put it in standard form, but there's going to be times in which it says put it in standard form, so we're going to do that too. Because now we've got complete the square, but there's a number on the front, right? So we start the same way. Y equals, group together the 2x squared plus 8x plus 7 goes on the outside. Then I'm going to take out the 2. I'm dividing this and this by 2, which means it's x squared plus 4x. Now I'm going to take that middle term, which is 4. 4 divided by 2 squared would be 2 squared, which is 4. I add it here. And normally I would subtract it from the 7. But because we took something out, I have to multiply it first. So now I am actually subtracting 8. So whatever you take out on the front has to get multiplied by that number before you subtract it from the end. So I get y equals 2 square root first term, square root third term, sign from the middle, put it in the parentheses and square it. So it's 2 times x plus 2 squared, and then 7 minus 8, which is negative 1. What's the vertex? Good. What's the axis symmetry? What's the x-coordinate on my vertex? Negative 2, good. Again, x equals negative 2. It has to be an equation. God bless you. Now we're going to find the x-intercepts. So this time, let's see if it's factorable. 2 times 7 would be 14. Are there factors of 14 that sum to 8? No. So you couldn't factor it. If you did that, and it worked, obviously, then I could factor it from the beginning. The last one was factorable. But this one is not. So you have to use your standard form or quadratic formula, but we're going to use standard form. Make y 0. So I'm going to add the 1. I'm going to divide by 2. Square root both sides of your equation, giving the plus and minus. It would be plus and minus 1 over the square root of 2 equals x plus 2. If that was a perfect square, I would continue to square root it and separate these out. It is not. So I'm just going to subtract the 2, and I'm going to say that my x-intercepts are negative 2 plus and minus 1 over root 2, which gets rationalized to root 2 over 2. Are you going to want to graph that? No, I would plug in different points, which I'll show you in a second, or use my y-intercept. But because it asked for it, my x-intercepts would be negative 2 minus square root 2 over 2, 0, and negative 2 plus square root 2 over 2, 0. So it might ask you for them, and you might not want to plot that. If you did, you would totally approximate. Like root 2 is like a 1.4, and then I'd divide that by 2, and I'd get negative 2 plus and minus 0.7. So I would have done 1.4 divided by 2, which is 0.7. So I can approximate this to be negative 2.7 and negative 1.3. But it might be easier to plug in some different points instead of using those. So you have to find it to answer the question, but you don't have to find it to graph it. Okay, and then y-intercept, remember, come all the way back up to the beginning. This would be 0, so this is gone. This would be 0, this is gone. My y-intercept is 0, 7. So my vertex, -2, -1. My y-intercept, 0, 7. And since I have that, I can reflect it over. So if I'm going up 1, 2, 3, 4, 5, 6, 7, 8, and to the right 2, I can go up 8, and to the left 2 to get the second point. You do not need to use those yucky intercepts to graph it, although it should be consistent with what we approximated it as, -2.7 and -1.3. Questions on that one? The third way, so we had just our like original monomial where there's only the x squareds. We found the vertex, we plug it in points. Then the second way, actually, so this would be the fourth way. Then the second way is if it was already in standard form. And so we found the vertex and then we used our like either plugging in points or we used the, if there was no vertical compression, to find the rest. The third way is if you force it into standard form, which is what we did, and that's what this is, right? The third way, or the fourth way, is that -b over 2a. So we're going to do one of those. But this one just says finding the standard form. So this is what we did. We plugged in the vertex. And, oh, sorry, this is finding the equation. Just kidding. This is finding the equation given the information. So if I give you the point, and I give you the vertex and a point, and you find the equation. And these, honestly, should be so easy. And every year somebody's like, I don't know if it's that you're burnt out by this point, so nothing sinks in. But all you're doing is plugging points in here and then solving your equation. So these should be pretty easy. So I would take something like this. You're going to get given the vertex and a coordinate point, and I'm going to plug it into standard form. So standard form is y equals, eventually we make it f of x, but y equals ax minus h squared plus k. Step one is have that memorized. Then your vertex is your h and your k, and your coordinate point is your x and your y. So you're going to plug in for everything except the a. So y is -6, a is our unknown, x is 3, minus h is 1, squared, plus 2. Biggest mistake I see made is people forgetting to square this, so don't forget that, okay? Whatever's in the parentheses gets squared. Now I get -6 equals a, 3 minus 1 squared would be 2 squared plus 2. Then we square it. And then you cannot combine the 4 and the 2, which is the other mistake people make. You have to subtract the 2. And I get -8 equals a times 4. And I divide both sides by 4. And I get a is -2. And now you plug back in just your h, your k, and your a. So I get y equals the a, which is -2, x minus the h, which is 1, squared, plus the k, which is 2. All right, we're going to do it one more time. So vertex is h, k, coordinate point is x, y. Y equals ax minus h squared plus k. So y is 5, a is my unknown, x is -6, h is -4, and it's minus a -4, so it becomes plus, squared, plus k, which is 11. 5 equals a times -2 squared plus 11. 5 equals a times 4 plus 11. If you want to rewrite, so like the 4's at the front so that you remembered you can't combine the 4 and 11, that's fine. But don't combine them. You have to subtract the 11. -6 equals a times 4. And then you have to divide by 4. -6 over 4, which is -3/2. And then I plug back in my h, my k, and my a. So y equals -3/2 x minus a -4 would become plus 4 squared plus 11. To the last thing, which looks like a heck of a lot of words, okay? But once you get the hang of it, it's really not that bad. Oh, sorry, this is the complete the square. So we already did this. We already did the complete the square part, okay? We grouped the ax squared and the bx together. If a was not 1, we factored it out. We found the middle term by doing b divided by 2 and then squaring it. We added it to the parentheses, subtracted from the c, and if we took something out, we multiplied it by that term first. We factored it, and then we put it in the complete the square or standard form. So this is how we did the complete the square. We already did this. The last thing, so instead of doing standard form, we're going to find it using negative b over 2a. So if it didn't say put it in standard form, and this is where you want to pay attention, like I flip-flop these, but if it had said just find the vertex, the y-intercepts, the x-intercepts, and the axis, then you really have two choices. One is put it in a standard form using complete the square. The other is doing what we're about to do, which I would strongly recommend because it's a lot easier, okay? But there are going to be questions on your quiz that say, put it into standard form, and then do all the things. So you would have to do complete the square. So the other method, or the last method, which this was at the notes all at the beginning, said negative b over 2a. So we find the x coordinate of our vertex by doing that. So if I look at this equation, what is a? Remember, it's ax squared plus bx plus c. So think that you're doing the quadratic formula. What's your a? 1. What's your b? Negative 6. C would be negative 3, but we don't even need it for this. So to find the x coordinate of your vertex, or h, we're going to do negative b over 2a. So negative 6 over 2 times 1 is 6 over 2, which is 3. And that's the x coordinate of your vertex. Now, to find the y coordinate, or the k, we're going to plug that x back into these x's. And then we plug it back in to get the y. So y equals, from here, I'm plugging back into these x's. So 9 minus 18 minus 3 is negative 9 minus 3, which is negative 12. And that's the y coordinate of your vertex. So I can plot those. 3, negative 12 is going to be down here. Is there a vertical stretch or compression on this? Is there a number on the front? No. So I can go up 1 and to the right 1. Or because it's asking for all that other information, I could find my y-intercept and my x-intercept. So my y-intercept comes from making x 0. And it's easiest to do this from the original point because these would cancel. And I'd get 0, negative 3. That's the y-intercept. The x-intercepts, this time I would want to see if it's factorable because we didn't already complete the square. Are there factors of negative 3 that sum to negative 6? No. Which means you could either force it in to complete the square or you could use the quadratic formula. That's your other option. So a review of quadratic formula, negative b plus and minus the square root of b squared minus 4ac all over 2a. So negative 6, which means 6 plus and minus the square root of negative 6 squared minus 4 times a times c all over 2 times a. And I get 6 plus and minus the square root of 36 plus 12 over 2. 6 plus and minus the square root of 48 over 2. If it wanted exact, I would break down that 48 so that this would be 3 and 16, 4 and 4. So the 4 goes to the outside. 3 plus and minus 2 root 3 would be my exact x-intercepts. So 3 minus 2 root 3, 0, and 3 plus 2 root 3, 0. Again, are you going to want to graph those? Is that fun to graph? You could approximate it, like root 3 is like a 1.4. You could approximate it. Or you can use your y-intercept. If I'm going from negative 12 to negative 3, I went up 9 and then 1, 2, 3 to the left. So I could do the same up 9, but 1, 2, 3 to the right. And I could get my second point that way, which is way easier. And then my axis of symmetry is x equals the h, which is 3. If it's not factorable and you didn't do standard form, then quadratic is your backup. If we had done this using standard form, like the instructions, like I crossed it out, but if the instructions had said standard form, we already practiced that a bunch, so I wanted to show this way. If it had already put in a quadratic form, and so we use complete the square, then I would have just made y 0, and then ended up with the even root property thing where you got to move it, square root both sides. But if it's not, like first of all, quadratic you can always fall back on because it works every single time. But if you didn't already do the work for complete the square, I would do that. Yeah.
On the other side, for the x-intercept, you always have to simplify it down.
No, I mean, so this is actually the homework's a PDF. And yes, you will give it to me because you want to practice that for the quiz. Yep, you want to give it to me as exact, which means simplify it. All right, I want you to jump to the last one. We're going to do just one more that way, okay? We're going to cancel out the standard form. And we're going to make this positive so that you can see what would happen if it was factorable too. Okay, so make those two changes. Cross out standard form and make that x squared positive. So we're not going to do standard form. We're going to do the negative b over 2a. So a is 1 after I make it positive. B is 3. Again, I don't need c. C is going to help me with my y-intercept, but I don't need it for my negative b over 2a. So then my h is going to be negative 3 over 2 times 1, which is negative 3 halves. That's the x coordinate of my vertex. To find the y coordinate of my vertex, I'm going to plug that back in. So I'm going to get negative 3 halves squared plus 3 times 3 halves, negative 3 halves, minus 4. I'm going to square the negative 3 halves, so I get 9 fourths. Multiply 3 times negative 3 halves, and I get negative 9 halves minus 4. I have to give them all the same denominator. So I'm going to multiply by 2 here. I get 9 over 4 minus 18 over 4. This would be over 1, so I have to multiply by 4 minus 16 over 4. So I gave them all the same denominator so I can combine them. I get negative 8 minus 16, which is negative 24 fourths, which is negative 6. That's the k coordinate of my vertex, so that's the y coordinate of my vertex. Now yep.
And negative 3 over 2 is the x squared.
Correct. Now the y-intercept, this would be 0 and this would be 0. It's just the c, which is negative 4. And the x-intercepts, I'm going to make y 0. And this time there are factors of -4 that sum to +3, so I'm going to factor this. I would get 0 equals x plus 4 and x minus 1. Split and solve. And I get x equals -4 and x equals +1. And then my axis of symmetry is x equals the x coordinate of my vertex, or h, which is -3/2. If you wanted to graph this, it didn't say it, but if you wanted to graph this, my vertex would be -1 1/2 and -6. My y-intercept is 0, -4, and my x-intercepts are -4 and +1. So I know we did a lot today. This is like a smack right in the face when you get back from break, okay? But we will practice everything that we just did tomorrow, and then we have to move on a little bit, but we will practice what we did tomorrow, and that is what your quiz will cover. So your quiz is going to have one that gets forced into standard form, one that you get the choice, one that you have to use -b over 2a, and then one in which you're doing the reverse where you get the information and have to do the equation. So it is 4 questions, but they have a lot of parts within them.